Lesson 9.1, graphing quadratic functions. So this is a combination of looking at quadratics. That means an equation that has a squared variable. Looking at what the graphs are, which are parabolas, and different information about the parabolas. So part of the objective is to graph the quadratic functions, but it's also to analyze characteristics of graphs of quadratic functions, find what's called the axis of symmetry, the vertex, the max and mins of quadratic functions. So that's a lot of new vocabulary, a lot of new things for us to cover here at the beginning of Chapter 9. The standards are Algebra 1, 8.1, 9.2, and also 6.8. Okay, so basically we'll go back to the beginning. A quadratic function has degree of 2. That means the exponent on the variable is a 2. We did a lot of stuff with this in the last couple of chapters we've covered. So I'm looking at function notation. And remember, on function notation, it's going to have this f of x, which really is what we put in place of our y, so y equals. But we have to write, since it's function notation, f of x equals. And it is ax squared plus bx plus c, where a, b, and c are going to be numbers that we use for different things. I will tell you this, a can never be 0 because then there wouldn't be a squared term and it wouldn't be a quadratic function. But I can tell you that b and or c could be zeros, okay? So those terms could not be there maybe, but you would still have a quadratic function. So this part right here, please don't leave that out. A cannot equal 0. If it did, it wouldn't have a degree of 2. That term would be gone. Question?
So A will never equal 0?
Correct. A will never be 0. Probably more often than not, A is going to be 1. And your function will start off with f of x equals x squared. So you won't see a number there, but it'd automatically be a 1. Okay, so these functions make a parabola. A parabola is this shape that you see right here. Okay, that is a parabola shape. Those sides keep getting further and further away. They very kind of sometimes hard to see. It's not just a complete U. The arrows are kind of going ever so slightly outward. That parabola could be up like that, or it could go downward. So concave up or concave down, that would be called. And now looking at the parabola, let me scroll down here just a little bit and show you a little bit more about it, some of those terms that we need to know. Okay, so you're going to be given these equations, okay? Ax squared plus bx plus c. And here's some things that you're going to have to know. The axis of symmetry. Well, a parabola is called symmetrical because if you cut it right down the middle where that dashed line is, you could flip it over and it would land on itself. Okay, that's what symmetrical is. So the axis of symmetry is this imaginary dashed vertical line that goes right down through the middle. The equation for that is always in this form. X equals negative b over 2 times a. So whatever these numbers are, you're going to be using them to find things like axis of symmetry. So again, it's going to be a vertical line. That's why it's x equal, and it's going to be x equals some number. The opposite of b over 2 times a. You're going to plug in those numbers. It's going to be really important when you get that function to go ahead and just write down what's my a, b, c, because you're going to start using it right off the bat. Okay. That's where you would put in your dashed line. Now, where the axis of symmetry intersects the parabola, so that point right there, it's called the vertex point. Zach?
Is that B negative or a small fraction?
The B is the opposite. So if B would be a positive number, you'd put in a negative. And if B would be a negative, you'd put in a positive. So it's the opposite of whatever B is. The vertex point is where the axis of symmetry hits the parabola. Okay, so we'll talk about how to get that also as we go through this. So that vertex would be an ordered pair. So it'll be an X number and a Y number. Whatever the axis of symmetry value is, that would be the X value in that point. Okay? That would be the X value because it crosses right there on the axis of symmetry. Also, the Y-intercept is C. The number at the end by itself is the Y-intercept. Okay, the number at the end by itself is the Y-intercept. And a couple of things, I told you that it could open up or open down. So if A, the number in front of your squared term, if it's greater than 0, in other words, if it's positive, that means the parabola opens up. And if it opens up, your vertex is called a min point. That means the lowest point, the minimum, the lowest point on the parabola. If A is less than 0, so if A is a negative value, then the parabola opens downward. It's upside down. And that vertex would be called a max point, a maximum point of the parabola. Okay, so it all is dependent upon the value of A. Positive, it opens up. Negative, it opens down. The vertex would either then be a max or a min, depending. Okay, so some other things that we need to discuss about this. Are there any questions about those things? This is just all kind of general information right now. Okay. You will also be asked, and this will be your first instance of this, but as you go on with Algebra 2 and calculus, or pre-calculus and calculus, you're always going to be asked to name the domain and range of the graph or of the function. The domain, do you remember talking about domain and range? Yeah, which ones are the domain, Maitri? Yeah, the domain are the x's, let's say, and the x's are always the set, and you use set notation, okay, that's what this is, all real numbers. You say you're going to use all real numbers for the domain as you're graphing, but the range is different. The range is the set of y's, and it depends on whatever the max and min is. So let's say this, just to maybe kind of give you an idea. If it is a parabola that goes like this, and you get this value, your range would be all of the y's from this point upward. Does that make sense? All of the y's from that point upward. Whereas if it's upside down, the y's would be from this point downward. You get what I'm saying? On a vertical axis for your x and y, it depends on whether it's a max or min and what that point actually is. Hopefully you'll understand that a little bit more once we do some examples. Okay, there's a lot of information that I'm giving you right now. I realize that. Okay, questions about knowing domain and range. Domain, you just always say all real numbers. Range, that one, it depends a little bit. Okay, so let's go on here and see what we've got. Maybe an example. Okay. All right, so here's what these problems will look like for you. Find the vertex, axis of symmetry, y-intercept, domain and range, and graph using a table of values. Oh my gosh, yes, we have to go back to table of values. That's not as fun as it might sound. Okay, going back to graphing using a table of values. That's what you did when we first started graphing lines. You'd put in numbers for X, solve, and find your matching Y points and graph using points. Okay, so we're going to start. We've got to find all these things, and I've got them listed. So when you guys do some on your own, I would go definitely back to this example and go step by step. I'm going to get rid of those directions so I can put as much as I can in here, because once I start writing, yeah, we'll see. I'm going to have to probably erase as I go. So, okay. Y equals x squared minus x minus 2. Okay, A, B, and C. A, B, and C. What do you think the value for A is? Any ideas? My tree? 1. What's the value for B, Jared? Good. -1. And what's the value of C? -2. Okay, so we need to do the axis of symmetry, and it shows us right here, x equals -b over 2a. This one's going to be great. So -b means -1, doesn't it? -1 over 2 times 1. Who's got what that really is? Who's got what that really is? Tora? 1/2. Thank heavens it's just 1/2. Okay, so you're plugging into that. You got your axis of symmetry. It's going to be a vertical line through x at 1/2. Okay, once you get that, your vertex, you have the first part already done. It's got to be, x has got to be 1/2, because that's where it goes through, that point. To get the rest of the vertex, you have to see what point matches that for the y. So you would say y equals, and you plug it in to the function. 1/2 squared minus 1/2 minus 2. Okay, more power to you if you got a calculator with the fraction button. So this would be 1/4 minus 1/2 minus 2. And if I go from there, it's going to be, I believe, -2 1/4, isn't it? Should be? Yes. Okay, and I'm going to make that, it's -2 1/4. Okay, we'll go with that, -2 1/4. You could also name that -9/4. Questions about that? Josh? Because we are going to be graphing, I can graph negative. It's going to be either way. You could do it either way. You can easily convert in between, but when I go to graph, I want to see -2 1/4 maybe for that reason. But you could do it either way. Olivia? You got it? Okay, so what's the y-intercept going to be? -2. What's the domain going to be? Easiest question, right? All real numbers, thank heavens. That's the easiest one. All real numbers. Okay, I'm going to stop this video and we'll pick up where we left off in a minute.